This next segment is on the role of water in hydraulic fracturing. Water associated with hydraulic fracturing is derived from local underground or surface sources and is either managed on-site or transported off-site for treatment and/or discharge. The water footprint of hydraulic fracturing depends on the formation, depth, and type of drilling, for example, vertical, horizontal, directional. Examples of water associated with the hydraulic fracturing life cycle include makeup water for mixing hydraulic fracturing fluids, fluids that flow back or are produced back to the surface during the course of energy resource extraction. Water is the most common and most heavily used fluid in the petroleum industry. Water is produced along with oil and gas from nearly every well. Water is used as a base fluid in the production, drilling, and completion operations. Water will be produced, recycled, injected, mixed, cleaned, and re-injected. Water's use and protection are emotionally charged subjects in many communities. This next graphic describes the water management cycle for oil and gas operations, beginning up in the top right corner with the acquisition of water or water source. Here we're talking about subsurface aquifers, rivers, lakes or ponds, rural or urban water supplies, gray water, even acid mine drainage. Water transport involves pipelines or trucking, getting water to the site. Water storage, this is on-site. This is done in steel frac tanks, which can hold 500 barrels, modular tanks, which can hold up to 40,000 barrels, or pits and ponds, which can hold up to 100,000 barrels of water. Moving into the stimulation part of the cycle, water used in this process is the water that's injected downhole, and as much as 10 million gallons can be used in a well. We then move to water treatment and reuse. Here, biocides, settling, filtration, electrical coagulation, distillation, crystallization are all methods that are used in water treatment. And then finally, water disposal through evaporation or water disposal wells. Marginal waters are another source of water for hydraulic fracturing. What are marginal waters? They're treated wastewater effluent, brackish groundwater, even flowback and produced water can be reused. Marginal waters are potential new sources, especially in times of drought. Marginal waters are typically water having over 5,000 ppm total dissolved solids, or TDS. Water of this type does not require a permit in some states. There is no competition between agriculture or city usage for these types of waters. It would relieve dependency on freshwater sources. One result would be increased public perception of good neighbors. And saline waters, for instance, are abundant and often no one else is currently using them. One of the problems with the use of marginal waters, particularly brackish or saline sources, is that they are not well characterized in the subsurface, either with respect to their exact location or their actual water quality. So more research needs to be done in this area. These pictures show some examples of how water can be stored. These include large impoundments, modular tanks, and steel tanks. So why is water storage important? Again, water is the base fluid and the biggest component of any hydraulic fracturing operation. Water volumes required for typical completions range from 2 to 10 million gallons per well. Water must be stored near the completion operation in sufficient quantities to finish a job at the desired pump rate for the injection. In the first 90 days after fracturing, a well can produce from 20 to 80% back to the surface. To recycle water, there has to be enough storage for both the dirty water and the processed clean water. Water must be stored in a manner that is economically and environmentally sound. In order to be in the oil and gas business today, you must also be in the water management business.